Good day, everyone. I am Ma'am Arteta and I will demonstrate the paired sample t-test. So paired sample t-test is used to determine whether the mean difference between the paired observation is statistically significant from different zero. Okay? And the participants are either the same individuals tested at the two time points or under the two different condition and the same dependent variable. So as what we can see here, the data is income versus year education. Select that worksheet and click OK. So wait for the data to be set up. Okay, so as what we can see here in the data view, the monthly income in years of education is our variables. So also, this is the variable view, which the labels, the measures, and the role is being presented. So to start with our process, we will go to transform and click compute table variable. So in this target variable box, we will type difference and we will transfer the dependent variable and independent variable, which is monthly income and years of education, inside the numeric expression box and type negative sign or minus sign and also transfer the years of education. So click OK. So as what we can see here in the data view, the difference is already been presented. Okay, to continue with our process, we will check its assumption. So go to Analyze and click Descriptive Statistics and click Explore. Now this Explore box will pop up and make sure to transfer the monthly income into the dependent list and as well the years of education. So click the plots. So as what we can see here, make sure that the stem and leaf descriptive box is unchecked and as well the box plot must be factors levels together and check the normality plots and click continue. Make sure also that the display is both and click OK. So we will check its outliers. So full screen, the screen. So as what we can see here, the two outliers were detected that were more than 1.5 box length, okay, from the edge of the box in the box plot. So inspection of their values did not reveal them to be extreme and they were kept in the analysis. Okay, so that's what we can see here in the monthly income. Okay, so continued with our process, we will also check its p-value. Okay, so looking in the test of normality, the difference score for the monthly income and years of education were normally distributed as assessed by the Shapiro-Wilk test. Okay, so the p-value in this is 0.014 and 0.04 okay. So in order to run the paired sample t-test, we will click again the analyze and click the compare means. So as what we can see here, we can see the paired sample t-test and click in that box and another box will pop out. Okay, so make sure to transfer the variables. One, that is the variable one, and also transfer the years of education. So after transferring the variables that is being highlighted, click the options and make sure that the confidence levels interval percentage is 95% and the missing value must be exclude cases analysis by analysis and click continue and also click OK. So after that process, we will interpret the result by looking into its descriptive statistics output table in the paired samples statistics table. Okay, so as what we can see here, in the box presented, the data are mean plus negative standard deviation unless otherwise stated. The data presented in the case processing summary, the sample's size is 10, okay? In pair 1, the years of education, the monthly income, which is equally distributed between the variables in the test of normality. Under the Shapiro-Wilks column, and the p-value must be greater than 0.05 in order to qualify for the normality test. As what we can see here of our normality table, it's shown that has the value of 0.014, okay, which is greater than 0.05. And our data set qualifies that the test for normality. So we can now proceed to the next process, which is to check the paired sample statistics table. So we will go back to the paired sample statistics table, and its arithmetic average is 53,900, and for the years of education is equivalent to 15.90, which is equivalent to 1 year and 4 months. So for the standard deviation error for the monthly income and standard deviation error mean, which is 10,446.105, which is far from the income, far from the mean value, which is 53,900. And our probability of committing errors is far from the mean of the variables in paired sample t-test, and the sig value must be less than 0.05. So since our result shows that the sig value is here, the sig value is 0.001, which means that the monthly income and the years of education are statistically significant, which means that we have the evident result to accept the alternative hypothesis. That's all. Thank you.
At this juncture, I will be demonstrating to you the independent sample t-test. By the way, my name is Marifel Siangot. Okay, so this would be our variable view for our independent sample t-test, and we will now go to our data view. So before I start on, as we all know that the independent sample t-test is used to compare the two samples of the means for the unrelated groups. So these means are different people providing scores for each group. So basically, the purpose of this test is to determine if the samples are different from each other. So we have five assumptions for our independent sample t-test. So since our first assumption is the dependent variable must be measured in continuous, so these scores basically is measured in continuous, and for our two groups, for the second assumption, this would be the blended and the modular. So prior, we will proceed to the step-by-step process on how to perform the independent sample t-test. We will first then label this intervention. So let's say the blended is labeled as 1, and what we are going to do is we need to copy for the entire content which has a blended. And for the modular, let's say this is 2, and we will control C and then paste it for the modular. Okay, so this is now our view for our intervention. And after that, we will go back to our variable view. For here in the string, we will set here numeric and then click OK. And for the labels, we will put here scores. And for these, this is intervention. So since our intervention has two groups, then we will put it here in the values level, let's say 1, which we referred earlier as blended, and click on add. And for 2, this is also modular. And then click on add and then click OK. And for the row, set this to none and then also this one to none. So this is now our setup for the independent sample t-test. Okay, so the very first process that we need to do is to click on Analyze and choose on Descriptive Statistic. Click on Explore, and then for the dependent list, we are going to transfer it here, our dependent variable, which is the score. And for the factor list, we are going to transfer it here, our interventions, and then click on display for plots, and the plots box will pop up. What we are going to do is to uncheck the stem and leaf and click on histogram, check for normality plot with test, and then click on continue, and then click OK. Okay, so we will now wait for the SPSS to load our data. Okay, so in the case processing summary, as we can observe, this is our blended rows, and this is our modular rows. So as we can observe in the n value here, which we have 10 sample size for both blended and modular. So for the test for normality, in order to qualify our data set for the test of normality, what we are going to look at is here in our Shapiro wheel column. So this sig or phi value must be greater than 0.05 in order to qualify for the test of normality. So since this is greater than 0.05 in both blended and modular, so we can say that this data set qualifies our test for normality. Okay, so since we are done with our assumptions tree, then we can proceed to the assumptions number 4. Okay, the next process that we are going to do is to click on Analyze and then go to Compared Means, and then under in Compared Means, choose on Independent Sample t-test. Okay, so what we are going to do here is we are going to transfer here the scores for our test variable, and for our intervention, we are going to transfer it here, our grouping variable. So since in our intervention, we have two groups, then we are going to define it in this defined group. So label it group 1 as 1 and 2 as 2. Okay, then click on options and then make sure that the confidence interval percentage must be set to 95%. Click OK, and then click on OK. So this is now our group statistics. table. So as you can observe, the mean score for the blended learning is 22, which means this is our arithmetic average, which they gained in the blended learning. And for the modular, we also have 16.90. So as we look at on the mean or the arithmetic average, we can say that the scores in blended learning is much greater than the modular learning. Okay, so the next table that we will look at is the independent sample t-test. Okay, so in the independent sample t-test, we will look at here in what we call this, the Levene's test for equality of variances. So for Levene's test for equality of variances, um, these two distributions are significantly different in scores by looking at the sig value here in our Levene's test. And this sig value must be greater than 0.05. So since our value is 375, which means that we will accept our alternative hypothesis and assume that the variances are approximately equal. Okay, so since, and now another thing that we will look on is our sig two-tailed value. So for our sig two-tailed value, this must be less than 0.05 in order to have what we call this capacity in order to accept or to support our alternative hypothesis. So since our sig value here is 0.001, so we can say that the blended and modular scores are statistically different from each other. So we can say that we have a significant evidence that we are going to accept our alternative hypothesis and to reject our null hypothesis using these values in the SPSS. So, and that's all for the independent sample t-test.
Hello again. I am back and I will demonstrate the one-way ANOVA. So let me define first what is ANOVA. ANOVA is to determine whether there are any statistically significant differences between the means of two or more independent groups. Note that the one-way ANOVA is also referred to as between subject ANOVA or one-way factor ANOVA. So, although it can be used with an independent variable with only two groups, the independent sample t-test is typically used in this situation instead. So, for this reason, you will come across the one-way ANOVA being described as a test to use when you have three or more groups rather than two or more groups. So always note that non-parametric equivalent is Kruskal-Wallis H-test. 4 is ordinal, and if nominal, that is chi-square. So let us first check if the data is already been set up. So we have here the independent variable to group 1 to 4 and our coping stress, which is our independent variable. So to start with, let us click directly our menu bar and find analyze and go directly to descriptive statistics and click explore. So make sure to transfer the data's physical level activity level, which is will be placed on the factor list, and coping with workplace stress is on the dependent list. So make sure also to click the plots, okay? And make sure that the descriptive box under the stem and leaf is unchecked, and the box plot must be factors level together, and check the normality plot with test, and the spread versus level with Levene's test must be none. and click continue. And let's check also the statistics. The descriptives and the confidence level must be 95% and click display must be both and click OK. Wait for the ANOVA result to be presented. Okay, so the table is now ready. So let's proceed now in looking into its outlier. So let's proceed to our value observed in this um, picture or graphs. So we have here the coping with workplace stress score and the physical activity level. So it shows that there were no outliers in the data as assessed by the inspection of the box plot. So in interpreting the data here in our test of normality result, so we will go directly in our sig or our p-value as what we can see here under the physical activity level column. The sedentary result p-value is 0.538. Meanwhile, the low is 0.059 and the moderate is 0.940 and the high is 0.671. So it means that the data is greater than 0.05 means we have qualified the test of normality. Okay, under the use of Shapiro-Wilks test. So for each group of our independent variable. So since it's done, we will now compare the means by going back and selecting in our menu bar and finding the analysis and click the analysis and go directly to compare means and click one way ANOVA. So on the top menu as shown below, we have already the pop-up box which we will have to transfer the independent and the dependent variable in the dependent list. Okay, here and also here. So factor. Okay, now we will proceed now in checking its options. We will make sure that the statistics descriptive must be checked, including the homogeneity and its Welch and the means plot. Make sure also to include the missing values and make sure that is mark exclude cases by analysis and click continue. Now we will also check its post hoc by checking its turquoise B's under the equal variances assumed turquoise B's and also the games how well must be checked under the equal variance not assumed. Make sure that the significance level must be 0.05 or greater than 0.05. So click continue. So once it is complete, we will click OK. So upon completing, we will proceed now in the effect size by clicking Analyze again, then click General Linear Model and click Univariate. So we will transfer the dependent variable, which is coping with workplace stress score here, and the physical activity level on the fixed factors or factor. Now, after that, we will select or check the estimates of effect size by clicking the options and under the display, we will check the estimates of effect size and make sure the significance level must be 0.05 and click continue and click OK. So after it is done, We will now interpret our results. So we will go directly on the descriptives result or table. So it shows that the mean is 4.15 and the low is 5.87 or 5.8. Moderate shows the mean, which is 7.12, and the high is 7.50 or 5. So it shows that the total sample on this mean is we have the total sample size is 31. Okay, so now we will proceed in the next part, which is the test of homogeneity variances. So look at this table, the test of variances. So as what we can see in the sig value, it shows the coping with workplace stress score is 0.120. So to interpret the table, the test of homogeneity of variances as assessed by the Levin's, Levin's test. So the statistics shows that in this case, since our data is greater than 0.05, and also we have successfully figure out that our means do have the equal variances and did not violated the assumption of the homogeneity. So it shows that our result is greater than 0.05. So that's it. Thank you for listening.
I will now be performing the one-way repeated measures ANOVA. So before I will start on one-way repeated measures ANOVA, this is also known as the within subject ANOVA. So this is used to determine whether three or more groups are different where the participants are the same. So we have here our dependent variable should be measured in interval or ratio. And for our independent variable, this must contain within subject factors which contains at least two or more categorical related groups. So by the way, this is our variable view for our one-way repeated measures ANOVA, and this will be our data view. So as you can observe here, we have three independent variables with related groups: pre, mid, and post C-reactive protein concentration. So the very first thing that we do in one-way repeated measures ANOVA is to click on Analyze tab, click on Descriptive Statistics, and then click on Explore. So since we have three dependent lists for this data set, what we are going to do is we are going to transfer it here on our dependent list. And then click on plots, and then the box plot will appear. And check the stem and leaf rather. Check for normality plot test, and then click on continue. And then click OK. Okay, so as you can observe in the case processing summary, our sample size for the three intervention is 10. And here for the test for normality under the Shapiro wheel column, as what you can observe, this sig value must be greater than 0.05 in order to qualify for our test for normality. So as you can observe, our value here in the Shapiro wheel column has a greater amount of a sig value, which is higher than 0.05, which means that our third assumptions qualifies the test for normality. And the next thing that we need to do is, of course, click again on Analyze tab, click on General Linear Model, and choose this repeated measures. And then on repeated measures, since in within subjects, we are measuring here the intervention, which is the time. And since we have three levels, so we put it here, three. And then for the measures, what we are measure here is the CRP, or the C-reactive protein concentration, and click on Add. And then click on Define. So the next steps that we are going to do is to click on what we are going to do is we need to transfer this within subjects variables in the next table. And then after this one, click on plots, and then on factors, transfer it here in horizontal axis, click on add, and then click continue. So here in post hoc, okay, we're done with the post hoc. Here in means is what we're going to display here is the time. Click compare main effects and choose Bonferroni. Click on continue. And here for the save, what we are going to choose here is to check the cooks and leverage values. And then the next is student size. And then after this one, click on continue and then click OK. Okay, so this is now our result with the one-way repeated measures ANOVA. So the thing that we need to look here is the what we call the Maltese test for sphericity. So as we can observe in a Maltese test sphericity, we are going to look at the result of the we call this p value, which is 0.43, and this is greater than the value of our sig is 0.05. And we can assume using this result that our variances are equal and the assumptions are not violated. So in this case, since it is greater than 0.05, we can say that we have met or fulfilled the assumptions of sphericity. Okay, the next table that we will look on is on what we call this. The next table that we would look on is in the within subject effects. So as you can observe it within subject effect, the sig value here must be less than 0.05. And in this case, we can say that in the exercise intervention in post, pre, mid, and post are statistically significant in change with the C reactive protein concentration. And we can actually look at the estimated marginal value, which means that the CRP here is decreases in our estimated marginal values. The CRP here is decreases in the pre-intervention to 3 months exercise until the post-exercise, which basically mean that we will accept our alternative hypothesis that there is a significant difference between the exercise intervention as well as the CRP program concentration. So that is our one-way repeated measures ANOVA. So as you can observe, there is a decrease when it comes to time level of estimated CRP concentration. So that was all for the one-way repeated measures ANOVA.
I will now demonstrate the correlational research. Now, what is correlational research? Correlational research are conducted to determine whether two variables are related to each other. We have here two variables or two groups, which is time spent watching TV, minute or day, and the cholesterol level. And we will allow to make prediction from one variable to another. Also, correlational research sometimes conducted when an experimental study is impractical or ethically impossible. So, example, it is ethically impossible to manipulate smoking and assess whether the smoking causes cancer in humans. So, we will now start with our step one, which is by checking the variables that are continuous and pair. So let's check the data view. So as what we can see, it is properly arranged and organized. So also, let's check the variable view. Okay, so it is good. So let us start with our first step, which is to check whether the linear relationship and the outliers to scatter plot by clicking graph and click chart builder. So since a tab pop up and we will have to click scatter plot and choose this image and we will have to drag it inside the box. And also, we will have to transfer the variables, the time spent watching into the x-axis and the cholesterol level, which will be our y-axis. So when checking, okay, so good. So the properties is set. Okay, the value is cholesterol concentration and let's click OK. Okay, so we will wait for the scatter plot will be presented. So it is now done. Now let's check the normality by clicking Analyze in the menu bar. And next, the descriptive statistics. And next is Explore. Then we will transfer its variable into the dependent list and also the cholesterol under the dependent list. So make sure that the displays both. Now we will check the statistics and plots. But first we will go in plots and note the descriptive box must be unchecked under the stem and leaf and the box plots must be none. And the normality plots must be checked and click continue. And of course, next is the statistics, which the descriptive box must be checked. And also, the confidence mean interval is 95%. And let's check continue and click the plots, display, and click continue. Now we will check its test of normality. Okay, so since the test of normality is being presented, we will check the p-value of time spent watching TV, which is 1.130, and for the cholesterol level, that is 0.065. So since it is presented, note that the p-value must be less than 0.05. Okay, so let's proceed with the next part or step, which is to run the person's correlation by bivariate procedure by clicking Analyze, and next Correlate, and check or click the bivariate then. Make sure to transfer the variables into the box and also the cholesterol. Okay, so since it is transferred, make sure that the correlation coefficient is person check, and the test of significance is two-tailed, and the flag significance correlation is checked. Okay, so we will check its correlation options. So make sure that the missing values must be in excluded cases pairwise, and click continue, and also here continue or okay. So we will go back to correlations table. Okay, so as what we can see, the time spent watching TV, the person correlation is 0.371. And also here in cholesterol level, its person correlation is 0.371. Okay, so we will now proceed to interpreting its result. Okay, so it is shown in our result that there was a moderate positive correlation between the daily time spent watching TV and the cholesterol concentration in males aged 45 to 65 years old. So the R value is 0.37 here. The R value is 0.37. Okay. So next is we will know its correlation. So therefore, its correlation table, the time spent watching TV has a moderate correlation with the value of 3.371 or 371, which means that the time spent watching TV has a moderate correlation in cholesterol level. So that's it. So it shows that correlation is significant at the 0.01 level to tail. So that's it. Thank you for listening. So we will now proceed with our next type, which is chi-square. So don't forget to save your work, Control S, and rename the file correlation practice. Okay, and click save.
Okay, so at this juncture, we will now proceed on multiple linear regression. So as we all know that multiple linear regression is an extension of our simple linear regression. So this can be used when we want to predict the value of our variables based on the two or more variables. So um, here for our multiple linear regression, our dependent variable is the VO2 max, and our independent variable is gender, heart rate, weight, age, as well as here the casino. And we will look back on the variable view. And for the gender, as you can observe, we have two groups here, the male and female. So since our data is now set up, then we will now proceed into its processes. But remember that in multiple linear regression, we have 8 assumptions that needs to qualify in order to run the multiple linear regression. And the first and the second assumptions are already met, which is a dependent variable must be measured in continuous. So as you can observe here in our VO2 max, this is measured in continuous. And for our independent variable, this is more than two variables here. So at this juncture, we will now go to the next process, which we will click on Analyze, and then choose the regression, and under the regression, click on Linear. And then the linear regression menu will pop up, and what we are going to do is we're going to transfer it, the dependent variable on the dependent row. So since our dependent variable is the VO2 max, we will transfer it there. And for the case of our independent variable, we are going to transfer it all into our independent variable row by clicking this arrow button. After this one, we will click on statistic, and on statistic, click on estimate, confidence interval under the regression coefficients, and then click on the model fit, descriptive, part and partial correlation, as well as collinearity diagnostics. And after this one, here in the residuals, we will click on Durbin Watson as well as case-wise diagnostic. And we will leave the standard deviation set into 3. After this one, we will click on continue and choose plot. So under in plots, we will check on the standardized residual plots. So what we're going to do is we need to check on histogram, normal probability plot, as well as produce all partial plots. And after that one, click on continue. And then another thing is we choose the save. And then under in the save tab, we will check on the unstandardized and then studenticize, and of course choose also studenticize deleted under the residual group. And then here in distances, we will choose on cooks as well as leverage values. And then do not forget to check on the include the covariance matrix rather, which can be located at the lower portion of this dialog box. And after that one, click on continue. And then click OK. So this is now the result of our multiple regression processes. So as you can observe in our descriptive statistics, the arithmetic average for our VO2 max is 43.62. The case number is in between 50.50. The average age is 31. The average weight is 79. And the average heart rate is 141. Okay, so here in correlations table, this shows to you how these variables relies to each other. And the next process that we would look on is the model summary. So here in our model summary table, was what you can observe here in our B. So this represents our dependent variable, which is the VO2 max. So in this case, our okay, so in this case, we would look at on our R column, which represents the quality of production for our dependent variables. So for this case, our VO2 value is 0.765, and this indicates a good level of our production as well as our R squared value. So for it to become a suitable model for our data set, this must be closer to 1 and the R square must be higher than 0.500. So in our case, this represents that our model suits our data. And under Endorphin Watson statistics, we would look on here, and this value must be greater or closer to 2 in order to ensure that no autocorrelation violates our assumption. And the next process that we would look on is on the coefficient table. So under here in our coefficient table, if the p-value, or what we call the sig, is less than 0.05, the coefficients are statistically significant. So given the T and the C column here in our coefficient, this tells us that the age, which is less than 0.05, the age, the weight, the heart rate are statistically significant but not on the case number, which is higher than point or greater than 0.05. And for the standard error of our coefficients in regression, this must be small as possible. For instance, in the heart rate, um, the value is 0.32, this which value is small. And for the collinearity statistics, which is the outermost part of this coefficient table, the collinearity statistic, this must be greater than 1.0. So in our case, since our values here for all our independent variable is greater than 1.0, so which means that the higher the values, the higher the multicollinearity between our variables. So putting it all together, given the four variables, the gender, age, weight, as well as the heart rate are statistically significant to the prediction of our p-value or sig, which is less than 0.05, which can be shown on the results of our coefficient table. And that's all for the processes and steps as well as interpretation for our multiple regression.
I am here again and I will demonstrate chi-square test of homogeneity. So let us define first what is chi-square test. So chi-square test homogeneity is 2 times C is used to determine if a difference exists between the binomial proportion of three or more independent groups on a dichotomous dependent variable. So it will let you determine whether the proportions are statistically significantly different in the different groups. So example, whether the proportions in each groups are equal in the population. So the chi-square test of homogeneity R times 2 is used to determine whether the two multimonial probability distributions are equal in the population. So that is whether there is statistically significant difference in the probabilities between two independent groups in terms of multimonial nomial dependent variable between two independent groups. Okay, so as what we can see here, we have two different independent groups, the babysitter and with the first aid course. So we will start by grouping its type of variables. So we have to know that we have only two types of babysitter. One, the first value 1, and the second is 2, which is the non-babysitter. Okay? So we will have to highlight first the data view in this first column. All the babysitter's word must be changed into number 1 or value number 1. So we will click one first here and clear that first cell, and we will have to highlight it again and control C and control V. So highlight everything. Okay. Now let's stop here and control V. So as what we can see, all the babysitter's word or variable is being changed with 1, and non-babysitter's word will be changed into value number 2. So we will have to highlight this cell and copy paste until this non-babysitter column. Okay, since this column is already been changed. Now we will have to do it again in this next column, which is with first aid course. Okay, so all babysitters with first aid course must be marked as one. So we will have to highlight this cell and change it into number one. So we will have to highlight it again. We will have to highlight the word one, the number one, and highlight this whole entire text with the babysitter with first aid kit course into number one, and also this one. Okay, so of course, this next variable, which is babysitter with no first aid course, must be marked as number two. So delete and change it into number two and highlight it again up until this babysitter with no first aid course into two and control V. So also here. Okay, so now let's proceed to the next variable, which is the value 2. Okay, so we will have to highlight this with a non-babysitter with first aid course. We will change it into number 3. Okay, so let's highlight this cell again, and we will have to highlight this whole non-babysitter with first aid course and control V. So of course, the last one is the non-babysitter with no first aid course must be marked as number 4 and control V. Okay, control V. Okay, good. Now we will check its variable view since the columns are already been set. Now we will check its type. So we will have to change it into numeric. Okay, change its variable type and click OK. And as well here in the next row. Okay, and click OK. Now next we will have to change its label into the word intervention. Intervention, and also here in the second row, intervention. Okay, next is its values. So we will have to um, input it as 1 being the babysitter and click add, and for the value 2, which is the non-babysitter. So also click add. So and click OK. So next for the row 2 is for the next value, which is the value number 1 must be the babysitter with first aid course, and click add. And number 2, babysitter without first aid course, and also click add. And for value 3, which is the non babysitter with first aid course. So that is number 3 and click add again. And the last one is number 4, which is um, the non babysitter without first aid course, and click add. So after completing, just click OK. So now we will proceed with the next column, which is the measure. So we will have to make sure that we will change it into ordinal, and also here in the row 2. So make sure also to change the row into none, and also here none. Okay, so since it's already been edited, we will proceed in our next step, which is to click its data view to double check our datas. Okay, so as what we can see, the datas has been already been grouped. Okay, so since we can see that we have 1, 2, 2 and 4, and also the 2 and 3, and 1, 1, 1, 2, and 1, 3, and the 2, 4 variables. So that is their indication. So after setting up the data, we will have to make sure that total count by clicking the data in the menu bar, and also go to weight cases in the bottom, and also we will have to change its into weight cases by, and we'll have to transfer this one and click OK. Now we will check its assumptions. So of course we will have to click again the analyze and find the descriptive statistics and click the cross tabs here. So after completing the process, we will have to transfer the intervention babysitter into its columns and rows. Okay, so just randomly select which one of the data you will put in rows and column. So next, we will have to make sure that our statistics is set and double check. So we will have to check the chi-square here, and also our, okay, so since it's already been okay, so we will have to click continue, and next we will check the cell display. So make sure to click or check the expected counts and uncheck the observe, and make sure to check under the z-test, compare the column proportions, and click adjust the p-value Bonferroni method. And also here under the percentage row, we will have to check the percentage and click column. Okay, and also we will have to check this non-integer weights, which is round cell counts. And since it's already been completed, easily click continue. Okay, let's double check if everything is has been set. Okay, so since none is being forgotten, we will have to click OK. So we will now proceed in our next step, which is checking its assumption, which will be done by Mom Marifel.
Okay, so thank you so much, Mom L. So now we will now proceed with the interpretation based on the perform steps, which was performed earlier by Mom L. So we will first look on into our case processing table, which will be located at the top of this table. Okay, let's take a look on the case processing table. So as you can observe in the case processing summary, for our interventions, we have a total sample of 279 sample size. And here in our cross tabulation, as you can observe, here for our babysitter with first aid course, we have 64 of it. And for the babysitter without first aid course, we also have 35. For non-babysitter with first aid course, we have 86. And for non-babysitter without first aid course is 94. So all in all, it sum up into 279 total respondents. So giving this cross tabulation table, we can look at that among the four interventions of our independent variable, the highest possible number for our intervention is the non-babysitter without first aid course, followed by our non-babysitter with first aid course. Third is the babysitter with first aid course, and lastly, the babysitter without first aid course. Okay, so after this one, we will look on our chi-square table, or what we call this, the chi-square test table. Okay, so here in a chi-square test, this is our chi-square table rather, and we will look at on what we call this asymptotic significance. So our asymptotic significance, this must be less than 0.01. So in order to have a statistical significant result of our p-value, this must be less than 0.05. So in our case, since our asymptotic significance is less than 0.05, we can say that there is a statistical significant difference between our four independent variables. Therefore, that we are going to reject our null hypothesis and accept our alternative hypothesis. So that's all for the chi-square interpretation.
Thank you for watching our video. Goodbye.